Hello again, friends. In this video we're going to be trying to find the area between two curves in terms of x using integration. So before we start using integration, I kind of wanted to recap a bit about some of the work we've done in the past, kind of see how we get like this idea of where integration is coming from. So in the past, when we were given two functions, right, you have two formulas and then bounds within from x equals 0 to x equals 3. So if we're going to graph these guys, we're going to start here, we're going to have a point here, we're going to have a point here, and we're going to have a point here, and same for the other side. And then when x equals 3 at our bounds, right, we know at 0 it's going to be 2, when x equals 3, it's going to be up here at 11. So our parabola is going to look like this. And our other graph is when y equals x, so that's just going to be the diagonal line like this. And then we're trying to find between when x equals 0, so that's our axis right there, and then when x equals 3, which is this guy right here. So what we're trying to find is we're trying to find this area in between here. Now, okay. So in the past what we've done is we've kind of built up our rectangles, right? We've drawn a rectangle in here, that was bad, and I'm going to get a marker that actually shows up instead of my lame green marker. Give me a second. We've drew rectangles in here for some distance, right? And we had either from the right or from the left. And we've calculated the area of just a rectangle all the way up. So we set some defined width, and then we've figured out what the height was by subtracting our top equation from our bottom equation, right? Because if we figure out the height from 0 to here to our parabola, and then we subtract out the height from our lower equation from our y equals x to here, then we minus the only thing we've gotten rid of this part here underneath, this guy, and all that's left is just the stuff in between the two. So by subtracting out the parabola equation from like the results for our height, for our y values from our parabola, from our line here, we get a height, and then we can take that height, multiply it by the width of our rectangle. For instance here I kind of have it drawn to 1, and we can do that for all the rectangles up through when y equals 3. So we'll have 3 rectangles, we add them all together, and that's an approximated area. So with keeping that in mind, we can kind of see how our formula when we use integration is very similar to that, right? We're taking our function on our top and subtracting out our function on the bottom and multiplying it by our width, which is our dx, which is like infinitely small width, right? And then when we integrate it, we'll be able to get our area, as we've seen in the past, that when we do integration, we get the area. So, but we need to remember we have to take our top function and subtract out the bottom. So let's kind of see how this all works out using our integration. So I'm going to redraw our work that we had over here. I'm going to make this a little bit longer though, because we're not going to be able to squeeze it all in. So let me fix this real quick, friends, and then we can get on that. So that was a 0. So let's call this our x-axis. So we're now going to 1, 2, 3, 1, 2, 3. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So we know we have a point here, we have a point here, here, and here. And I'm only just going to draw the one side because that's the only side we're really working with, since we're going from 0, right, to when it's 3. So, and then we know that we have a point here, and here, and so on, diagonally forever. For our when y equals x, and we know that our bounds, like I said, are along our y-axis and along this guy right here. So we're trying to find the area in the middle. So once again, if we draw a rectangle in there, for example, we're going to be going from some dx width, and then our height is going to be determined. Our height is going to be determined by the top function minus our bottom function. So that, because we're going to take the from here to here, and we're going to subtract out from here to here, and get left with only the stuff that's in the middle here. So when we plug it all into our beautiful integral that we have going on over here, we're going to see we're going to have the integral, and that doesn't show up very well, so I'm going to switch my markers really quick. We're going to have the integral, and our lower bound is 0 to 3, went from 0 to 3, and our top function is x squared plus 2. It's our parabola, and then we're going to subtract out our bottom function, which is just x, and we're going from dx. So now we're going to rewrite this so it looks a little nicer. I'm just going to squeeze it all together. Minus x plus 2 dx, and we're doing integral. So when we take the integral, we are going to add 1 to our exponent and multiply by the reciprocal. We're going to add 1, so we have 1 here, so we're going to have 2, we have minus 1/2. And then finally we are going to add a 1x to our guy right here, and now we have to evaluate from 0 to 3. So doing that, we're going to plug in 1/3, 3 times 3 minus 1/2, 3 squared plus 2 times 3, all of that, and then we're going to subtract out when we plug 0 in, so plug 0, 0, 0, that's just going to be a big fat whopping 0, so I don't even have to really think about that one. And then when we evaluate all of this, plug it into our calculator, or finish, adding up our fractions and solving things out, what we're going to get is 21/2. And you can't see the 2, but that's a 2. 21/2, and that is our area between these two curves right here.